So here's a problem. We're going 10 meters east, right? And then we're going to go 8 meters at an angle south of west, 40 degrees south of west. And we're looking for our displacement. We're trying to find out where we ended up. So this is the vector that we're looking for, this one right here. Once again, you cannot simply just say a squared b squared equals c squared. Okay, it's not a right triangle here. So you're looking again for this resultant. You do want to be able to get to a squared b squared c squared. And so kind of the big picture of what you're trying to do is if we can construct a triangle that looks, say, like this, and if we can find this side and this side, then we can go ahead and find the result. Alright, so that's kind of the big picture. So let's do that. To do that, we're going to break apart all of our vectors into pure x's and pure y's. So this one, the green vector, we don't have to mess with. It's already an x component already. This we do have to fix. Alright, so you could draw your triangle across and down. I'm going to actually do it differently. I'm going to go down and across. And some of you might have gone across and down. That's fine. I'm just going to do it this way so there's no overlapping. It looks a little bit nicer when I do it like this. Alright, so we're going to try to find the two pieces, the two components, the x here and the y. Now, in my new triangle, I don't have any angles, but I can easily find some angles, right? For example, what's this angle right here? If this is 40, then this is 50 degrees, right? Or you could have also found this angle here. What would this angle be? 40. So either way, it doesn't really matter. So I'm going to just stick with this one. So we'll go 50 here. Oops, did I write x? This is supposed to be what? Y. This is x. Okay, so let's go ahead and find these two. So this component right here, let's use the 50 degrees. This is the adjacent side. Do I use cosine or sine for the adjacent? Cosine, so this is going to be 8 cosine of 50. Okay, and what's the answer for that? Okay, and then let's find this side over here. This is going to be opposite, so what's the shortcut? 8 sine of 50. And notice if you would have used the cosine, that's okay. If you would have used this angle here, 40 over here, this one would have been 8 sine of 40, and this one would have been 8 cosine of 40. But remember, with complementary angles, the sines and the cosines give you the same value. So anyway, what's this number? 13? Okay, so there we go. So we got those two sides. Now hopefully if you've drawn it like this, everything should just kind of fall into place where you're going to go from here. So for example, we're looking for these two sides. Well, let's do the easy one first. What's this side going to be? 5.14. That's the same, right? So that should be 5.14. Okay, and then what about this one? 10 minus 6.13, right? These two should add up to the total. This would be 10 minus 6.13. So that gives us 3.87. So we've now found the two x and y components, and so now it should be fairly straightforward to get the rest. I'm just going to pull my triangle out a little bit. 5.14, let's clean it up. 387, we're looking for this. So we're looking for the hypotenuse. We're going to use the Pythagorean theorem. 5.14 squared plus 3.87 squared equals our c, right, or whatever we want to call it, squared. Solve for c. 6 point something meters. Alright, we also have to get the angle. So we're going to look at our picture here. There's two angles. Which one do I want? Angle 1 or angle 2? Angle 1 or angle 2? Angle 1. Remember, our angle is always the angle where we started, right here. You also want to make sure it makes conceptual sense. This direction is southeasterly. This is southeasterly angle. This is northwesterly. It doesn't make sense. So make sure the angle makes sense. All right, tangent theta equals 387 divided by 514. Solve for theta. Inverse tangent this. And what do we get for theta? 0.0? Okay, and taking a look at this angle here, how are we going to describe this angle? Is this south of east or east of south? East of south. Okay, so our answer is 6.43 at 37 degrees east of south. Now, just kind of a little side note here. You could have drawn your orange triangle slightly different. You could have gone across and down. That's fine. What would have been different? Did anyone do it like that, where they went across and down? Nobody did? If you did that, that's fine. You would just get a slightly different direction. What would this angle be right here? 53 degrees south of east. So there's always going to be two ways you can specify your direction, and it really just depends on how you drew this triangle. If you drew it like I did, it's east to south. If you drew it across and down, that would be south of east.